As we begin this lesson, you need to have your index cards ready. So take a moment and do your index cards. One for linear, one for quadratic, one for absolute value, one for cubic, one for square root, one for exponential, and one for simple rational functions. Now, we may break these into 2 videos if the time becomes too long. The first graph that we are going to do is called linear equations. Now, you have had this before, and you've had y equals mx plus b. Remember, m is your slope, b is your y-intercept. If I want to graph something simple like y equals x plus 1, okay, then we go to the y-axis and we put a point at 1, and our slope is also 1, which is up 1 over 1. Again, up 1 to the right 1. Now, this becomes a nice straight line, and we are going to graph just like this. Now, it would be very helpful to use a ruler, which I have, but it's hard to hold the phone and the camera and draw the line with the ruler. So, linear function, y equals mx plus b. We've graphed a simple equation of y equals x plus 1. Reviewing, your slope is rising. Your y-intercept is at 0, 1. Your y-intercept is at 0, 1. The next one is quadratic. Now, you may or may not know the standard form. You have y equals a x minus h squared plus k. This is a big formula. Now, you need to know this formula. hk are your vertex, and that's where we will start. So we're going to graph y equals x minus 2 squared plus 1. X minus 2 squared plus 1. Now, our vertex is at 2, 1. The x goes to be the opposite, the y stays the same. So we're going to come over here to 2, over 2, up 1, over 2, up 1. Now, I'm going to insert a negative here, just so it's easier for us to graph. Everything we've done is put us into this first quadrant, and we need to graph. From this vertex, you want to go 1 point to the right, 1 point to the left. If I plug in 3 minus 2 is 1. 1 squared is still 1. This becomes negative 1 plus 1, which means that we're at 0. If I put in 1, 1 minus 2 is negative 1. Negative 1 squared is 1. Negative 1 plus 1 is again 0. Now we're going to go out 1 more point. This point here is at 4. 4 minus 2 is 2. 2 squared is 4. This makes it negative 4 plus 1. So 1, 2, 3. We're down here at negative 3. Okay, when I plug in 0, 0 minus 2 is negative 2. Negative 2 squared is 4. Negative 4 plus 1 is again negative 3. Now, we are going to connect our points to have a nice smooth curve. Nice smooth curve with our little arrows at the end. Now, let's look. This is our vertex. From negative infinity up to 1, up to positive 2, 1, we're rising. From the vertex down, we are decreasing. This is a rising part of the graph, or increasing. This is a decreasing part of the graph. Standard form or parent function. A x minus h squared plus k. Okay, this negative is your a. It affects the width and direction. I just have it affecting direction right now. Now, your third one. is absolute value. When I write absolute value, you're going to see that the absolute value looks very similar to the quadratic that I just did. Very similar. We have absolute value bars, but we have no square. HK is again your vertex, and I'm going to mark that. HK is your vertex. And now we're going to graph an example. We're going to have y equals negative x minus 2 minus 2. And our vertex is at 2, negative 2. 2, negative 2. So I go over 2 and I go down 2. Now I'm going to plug in this point here of 3. 3 minus 2 is 1. The absolute value of 1 is 1. Negative 1 minus 2 gives us negative 3. Okay, if I plug in 1, 1 minus 2 is negative 1. Positive 1 for absolute value, since absolute value measures distance. Negative 1 minus 2 is negative 3. One more point. We're going to plug in 4. 4 minus 2 is 2. Negative 2 minus 2. I'm going to go over here to negative 2, down here to negative 4. We're going to plug in over here. Oops, this one I plugged in at the wrong place. I'm off by 1. Let's move it over. Let's move this over. This needs to be here. Okay, now I'm going to plug in 0. 0 minus 2 is negative 2. Positive 2 for absolute value. Negative 2 minus 2 is negative 4. And we're going to connect our points. See how well I can hold this steady. And we're going to come this way, and we're going to put arrows on each end. So we have our vertex, we have our increasing, and we have our decreasing. Now, there are several more graphs, but I'm going to break these graphs into separate videos.